So Scott Walter was hanging out up in the northern parts, way up in Michigan or someplace where it actually gets cold.
Yeah.
Scott, do you like it where it's cold?
Oh, well, I like it where it's cold when it's warm.
I see, I see. Where, yeah.
The summers when it starts turning fallish and something like that. So yeah, I'm still in the abode up here in Michigan for the rest of this week, and I'll be going back to warmer weathers. But it's still nice here. It gets cool at night.
Yeah. Yeah, no, it's beautiful weather in September and October. Absolutely. So you're and then so you're not going to be around for the launch Friday morning.
Correct. So if it goes off, so there is a launch on the 6th, which is the Polaris Dawn, which has been delayed a little bit for a couple of reasons. One is because of like a minor incident with booster 1062 that I mean really should not have any impact on launch schedules did, but the real reason is that the weather has not really been cooperative enough for Polaris Dawn. So remember that they have to you have to have good weather in the Cape. You'd like to have good weather for the recovery of the booster, but in their case, the booster comes back. So usually the weather on the Cape and the weather around where the booster is going to return out there is going to be kind of similar because you're kind of close. But because this is a crewed mission, you have a lot of potential recovery zones along the flight path, which goes actually up the Atlantic seaboard. And if the weather there is not cooperative, then it's like, okay, we're not going to do this until. So it looks like they had a lot of days of very uncooperative weather, which is why they pushed everything back. There was, I think, ironically, like a helium leak on the booster on one of the first attempts they were going to do about 10 days ago, I think it was almost.
Yeah.
But it seems like they have that in order. So the official date, I think, is this September 6th. So that will be this Friday. And again, it's like their launches, usually the Starlink launches go south. And these, like I say, go up the Atlantic seaboard. And it's going to be the same inclination as the ISS, but not the same orbital plane. So they will not actually be able to rendezvous or anything like that. They're probably just choosing that because, like, hey, we know this route.
This route.
It's just there's no reason to pick anything different. Let's just go ahead and stick with it.
We've been down this road before.
Mm-hmm.
All right, so there hasn't been a tremendous amount of humanoid robot news the last few weeks, but there was one piece of news last week, which I have to admit, I kind of gleaned over. I was on so many other things last week, so many things that were happening that it just became, I just really saw the video and I just went, I'm not sure that's anything, but you're telling me that I missed out. So this will be completely.
We've been following it for a while, this particular company. So we know there are a lot of companies out there in space. It's hard to keep track because new ones pop up here and there. But there are a bunch of stalwarts that have been out there for a while, preceding the Tesla bot. We've talked about Sanctuary, which is based up in Vancouver a few times. We've probably talked about Apptronics, which is down in Austin. Of course, everyone knows Boston Dynamics, or the OG one out of Boston's been around. But these companies, Boston Dynamics goes back at least 30 years. These other two were formed around 2015, and there's another one that's also formed around the same time, or someone might have been like 2018 or something like that, but in the teens. But 1X Technologies out of Norway, they have two headquarters, one in Norway and one in Sunnyvale. So like most of their AI and stuff like that is being done there. They've been around since 2015, kind of working on this problem and ramping up, and they've had investments from OpenAI and everything else. So they're not a startup. They've been not so much in stealth mode. I mean, we've seen some videos from it. They have had the Eve bot that's been going around that's on the mobile platform. So they're a serious player. Plus, I mean, there's all these others that are coming up in China. It's hard to keep track of them, especially after the Shanghai show. I mean, there's just so many of them. And I think even P&D Robotics put out something yesterday showing again the evolution of their bot, that they're able to mass, let's say they produce quite a good number of them, probably in the order of at least several dozen at this point. And they may also have a hand now. But we'll come back to that as we kind of get into to what 1X. Now, I had the opportunity Herbert, John, myself have interviewed the CEO of 𝐂𝐦𝐚𝐢𝐥, Bernack, before, back in the spring, and their approach is to go like straight into the home.
Wow.
They're not going into the factory, and to go in the home is a very different environment than in the factory.
Yeah.
So you have your bot has to be safe. So right now, whatever we've seen from Figure or Tesla bot or Apptronic, those are not bots, or even the Chinese bots are doing backflips and stuff like that. You don't really want them in the home,
No.
even though there is one company that's sort of selling one for the home. It is they're even though they're not as dangerous as an industrial robot, there's still some dangers around them that you'd want to be concerned with. And so even in the factory environments, they're not certified yet. So all of them, when they're running in the factory, they're running in a mode that they actually have to make sure they cordon them off from the humans. So that,
Sure.
and ideally, it's like you want them to be there, because it's kind of silly that we've got this thing protecting the bots from the humans, and then something protecting the bot from the other bots, which was usually meant to be the cage to prevent the humans from getting it.
Right.
So, I mean, you're just adding too many moats, it seemed like, along the way. You get through there, and ideally you want to get rid of them. And that comes down to the certification of coming up with a bot that is not going to cause any potential physical injury if something goes wrong. So what could go wrong with a bot? One of them is it could fall on you, and if it's really heavy, it might hurt. So you try to make sure there's no sharp edges, everything is kind of smooth and round. You try to soften things, so in the event that something like that happens. But one of the best things to prevent that is to make sure it's not heavy to begin with. And the other is you have to make sure they're not too strong. So that if they're moving around and they actually hit you or run into you or something like that, it's not going to cause a lot of thing. And it turns out there's just because an arm seems like it's moving slowly, if it still has like a lot of rotational inertia in there because of the gearing, it can still continue to strike you. So you could have something that appears to be like a light object and it's coming into you, and when it bumps into you, rather than stopping, it still has to go because it has a lot of inertia and energy you're going to get rid of. And that's like a problem. The industrial robots have always had that it's like they're not back drivable. They hit you, they keep moving forward.
Yeah.
Until that energy gets dissipated somehow. And so the same thing you'd have to do with a bot in the home. So maybe not leave everyone pins and needles. You have a little video you want to show?
Yeah, we're gonna do that right now. Sure.
Yep.
So we have this little video. What do you want me to do with it?
Okay, that's a teaser video. And actually, are you at the beginning? But let's go ahead and run this. So it's like a 30-second teaser video.
Oh, okay.
That shows the NeoBot. And the first thing everyone notices is like it's got some sort of outer garment that it wears, looks like a tracksuit, which is one of the forms of protection between the mechanics that are in there, and also make it a little bit softer.
And for some reason, my computer is not letting me.
X is always great at that. You almost like have to like redo the whole thing.
Oh my goodness.
Once you get in the middle of a video in X, it's not as easy as like with YouTube where it goes back. Yeah.
Wow.
It
I've
just
never had
stalls.
this before.
Oh, I have that all the time.
So what are you saying you think I need to do?
You need to like kill it and start again.
Kill it and start again. Okay.
Yep.
It's
like the only thing. It just gets itself caught in that loop.
I gotta go down here.
Yeah, maybe just click on the Neo site. Just go ahead and go right to their post directly.
Oh.
Not even run it from there. Just go straight to their site. Yeah, just click down right where it says Neo. Right there. Yeah, go ahead and click. No, down a little bit more. A little bit more. Get to them directly. So you get out of my post and go straight to.
Yeah, I'm not seeing the link.
Oh, just click it. It should work.
Right here?
Click on. No, down.
No. The actual
thing. There you go. There you go. Okay, now you're actually on the Neo post directly. Okay. And now then you can pause it. Hopefully pause it. Yep. Hopefully pause it. Make it big, and then try again. There we go. All right. Okay, so here's the 30-second teaser, where you see the idea of the robot being helpful in a household, being able to pick up an object, in this case, a backpack. And again, we can see pretty nice looking hands there, which I'm going to talk quite a bit about. and you get an idea of the size of the bot and the fact that it is something that you would want to be around, as far as, it's not going to hurt or injure you if you were to bump into it.
Okay.
So, what are some of the things that you noticed about that? I
Well,
want to
one
hear
would
your.
be one would be this, of course, it's dressed and kind of looks more human-like in appearance, but then also the smoothness of the activities that it did, as well as the speed of the arm movement there near the end. That was impressive. When it was way more human-like in that speed, and that's what one of the things I've been waiting for, is to see not just an application accomplished, but at a human-like speed, so it feels less clunky.
Right. So that's what most people notice, is that it seemed to be very human-like motion, which they've been able to do from a lot of the training they have. Now, my understanding that in this particular case, to put it, is that it was telerobotically controlled during this, which is part of the reason for the smoothness, and part of the reason why it's not walking in this case, because when you're doing telerobotics, usually the walking is not included in yet, but it can walk. It's just starting to do it. And this is an evolution from their Eve bot, which was on wheels. And their Eve bot has been around for a couple of years and has been doing a lot of training and is actually able to accomplish a lot of things. The thing is, it did not have like full hands. It just had some very simple pincers, were actually off-the-shelf grippers from Robotique. In this case, they've gone to what they call a 20-degree freedom hand. But if you want to compare apples to oranges, it's like a 23-degree of freedom hand compared to the 22-degree of freedom hand that Tesla's coming out with.
Oh, wow.
Because they have an extra knuckle in the thumb.
Huh.
Because our thumb actually has 3 knuckles. It doesn't have 2.
Got it.
And again, we haven't seen what the Tesla 22-degree freedom hand is going to look like. We've made a lot of assumptions about what it is. And one of them is that 3 of the degrees of freedom are at the wrist, whereas the 20 degrees of freedom that Neo is, or that 1X is talking about, does not include the wrist in there. But you sort of should, because it's got the same kind of idea that the 22 DOF hand coming from Tesla one. So if you want to get an idea what the Tesla bot hand is going to look like, that is about as close as you're going to get to be able to see it. It already has, finger links, which are unique. They're the same for like a human hand, rather than them all being the same.
Right.
The proper knuckles in there. They can do the movement this way. I don't know if it can do separate movement, what you would need for the Vulcan symbol, or, whether it's just like able to splay out like that. Very good dexterity. It has some tactile sensors that are in there as well. And it's a very thin palm. When you look at it from edge on, it's like, oh, it's extremely thin. So right now, that's probably the best robotic hand we're going to see out there. And yes, that is a hand on there, and that's not a guy in a suit. Okay, it's definitely not a guy in a suit.
Right.
The mechanics they have are very, very unique. Now, the walking, they're just starting to learn to walk, because their previous bot was actually on wheels.
Right.
And they learned a lot about that. It's like, well, wheels can be very simple, but they actually are not going to be very useful in many, many applications. Partly because the footprint of your wheels is always very big. It's very hard to go through narrow areas and step over stuff with wheels. And in the home, it's a minefield that you're kind of going around every time. And you don't want this thing that has a very wide stance going around. With feet, you can have a narrow stance or a wide stance and literally just kind of step where you want to without having to roll over everything. As far as the efficiency, it turns out that your bipedal efficiency can be about as good as it is with wheels, believe it or not. We are very efficient. We've evolved to be extremely efficient in our walking motion. And the way that Bernd has kind of talked about it is like, if you really think about it, your legs are like a big wheel where you have like every leg is a spoke with a wheel. But rather than your leg going all the way around like with a wheel, once it kind of goes forward, it just kind of swings back and gets used again. So we have what is almost a rolling motion with our walking, was very efficient, but then allows us to go over uneven material, upstairs, do all these other things.
Backwards, sideways.
Yeah, and he kind of refers to the legs as things that manipulate the ground, because it's more than just walking. That when you were doing a lot of things, your legs are very much involved. So if you're leaning up against a cabinet, sometimes you're using your knee or your thigh or something like that to support you to get the kind of balance you have. Really hard to do it with wheeled vehicles, even though it seems at first like that's the easy way to go. So when you start talking to everyone out there, because they always ask the question, just put them on wheels, wheels be easier. There's like, it doesn't quite have solve the problems that everyone thinks it's going to solve. And then you get someone who actually put it on wheels and is like, that's not the way we're going to go. We're going to go to the full bipedalism. Now, this is a 5'5" bot, which is about where you want to be. It's sort of that 50% from 50th percentile as far as size. And they've managed. Oh, do you know how much the Tesla bot weighs? Do you
125 is what I remember. 125 pounds.
Well, that's kind of the spec that they have. We don't know that they've actually hit that yet.
Uh-huh.
That comes in the order of, okay, so let's say that they're actually at that. Do you know how much this one weighs?
No idea.
66 pounds.
66 pounds.
Yes.
Wow.
Exactly. So you're talking about this thing being almost half the mass.
Wow.
And so when this falls on you, it's not going to hurt. And it's rather remarkable that they've been able to get it down to that size through a variety of things. One of them is taking the safety only approach, is that they've really talked about, what does it need to build in safety? And once you do that, kind of build your bot out. Their actuator design is very unique and very different. That allows them both for the safety, and it could be for the power requirements as well. So they're targeting 2 to 4 hours of operation with this.
Okay.
So how big a battery pack do you think you would need for that many hours of operation?
Yeah, I mean, this is where you lose me, Scott, because I don't get into that.
So Optimus is like 2.3 kilowatt hours,
Okay.
and it's like looking for 4 to 8 hours of operation.
Uh-huh.
So you would think, oh, they're looking at about half of that. So this must be probably around 1,000 kilowatt hours or something like that. Their battery pack is 500.
500, yeah.
And it turns out that the way they've done the actuator design and everything, their power consumption is way below what everyone else is.
Wow.
So everyone else is that the inference is like part of it, but the inference might be 20-30% of what you need. For them, the inference is almost the majority.
Huh.
And they're still using the same amount of power that everyone else is for the inference.
Wow.
And that's because they almost don't need anything for their actuators because of the way they've been designed. The other thing is that if you watch this video and turn the sound on and listen to it, you'll notice there's something missing. And that is, you can't hear the actuators. You don't hear them grinding and moving around and doing everything else. And there's a lot of reasons for that. One is that when you are hearing noise coming from a motor, what are you hearing?
Gosh, I would think that what would you be hearing? You're hearing the spinning.
Basically, you're hearing loss, okay?
You're hearing loss, okay.
Sound is energy production, and sound has absolutely nothing to do with like the mechanical energy you want. It's an indication of loss. So the louder something is, the more lossy something is.
Oh, something's grinding against something else.
Other reasons you're hearing that is because of the transmission system and everything else that's in there. And so transmission systems are also producing a lot of heat and everything else. So when something is quiet, there's a good chance it's very efficient. And this is very efficient. And part of it is they don't have highly geared transmission system. They're almost direct drive, where the direct drive being like a gear ratio of 1 to 1 or 1 to 2.
Yeah.
Whereas most of the humanoid bots out there are having gear ratios like 1 to 100. And that's significance. And it's also a mass penalty because you got to build the transmission system for that. You need a gearbox, and there are harmonic drives and everything else. And harmonic drives, while they solve this backlash problem, they solve the backlash problem by making your gears very rigid, the way the teeth are like always next to each other. So the teeth are like constantly gnashing against each other, which is why you get a lot of noise from them. So so in this case, they've designed something which is more direct drive, and they're also using a tendon drive. And that has resulted in them not requiring as much power, it being very, very quiet. And also, because of the low gear ratio, it's extremely safe. It's very back drivable, which means when you bump into it, you can push it out of the way. Whereas when you have a gearbox that's highly geared, you cannot back drive it. It's like it's really difficult. The amount of torque you have to put on there to be able to make it spin backwards it's like virtually impossible. You cannot apply that amount of force. And the other thing it means is that if you're moving at a normal speed like this, and I have a motor that's right here on my elbow, and the motor's got a gearbox in there. So if it's geared 100 to 1, that means the rotor inside that motor is spinning 100 times faster than my arm is.
Okay, 100 times faster.
Right? 100 times faster. Yeah,
Yeah.
it has to be, right? Because the gearing. So
Yeah.
I've got a motor that's spinning 100 times faster, and I've got this gearing
Right.
to slow it down,
Right.
to be able to get it, because that's what I need to get my torque. But you've got a spinning mass there, and that has inertia, and the energy that's in there goes as the square of the velocity. So that means if you square 100, that's 10,000. That means the rotational energy that you're getting in that motor is like 10,000 times more than if you had something that was like a direct drive.
Oh.
They can take that and say that it's almost like the equivalent of, like, if I was moving my hand, if I was holding like a 20-pound kettlebell in my hand. So Randy, I come up to you and I'm moving like this, and I'm holding that mass there.
Yeah.
And I hit you.
Yeah, it's
That's gonna hurt.
Yeah.
Okay, that's gonna hurt. So, but I can do it with my arm, and it doesn't, because I don't have a highly gear ratioed servo motor down here at my elbow.
Right.
And that's where they get the safety from. The other thing is, by getting rid of the gearbox, they get rid of half their mass right there. I did a simple calculation with my little Optimus mass calculator. It said, what if I take all the actuators in Optimus and divide the masses in half? And what if I take the power pack and make it the same size?
Right. Yeah.
Because the Optimus power pack weighs about 10 kilograms, and the one from 1X is like around 2 kilograms.
Right.
So, significant there. I put it all together, boop, Optimus comes out around 30 kilograms, which is what these guys have. Okay. So it's like, oh, so I mean, it's as simple. So everything else is going to be the same. The mass of the cameras and the structure in the frame and all that you have is going to be about similar. And they've managed to do that, and because their motors are a lot lighter, and since a lot safer, and they consume less power as a result. Now, our friend Sadie Park was able to find patents for me that they've come up with, and they do have a patent out there describing how the robotic arm is. And I had to read it like 3 or 4 times, and the more I read it, the more like, oh my goodness, this is genius. It's really something else they came up with that I'm trying to understand more and more how it works. So they have a tendon drive, and that makes sense. I mean, Figure and Tesla and 𝐓𝐡𝐿𝐿tronics and others, they all have tendon drive in the fingers. Okay. It's like at some point you need to have tendons. And of course, we know Tesla's deciding to move it back there, but they do tendon drives like literally everywhere. And now we can't see what's behind the tracksuit. As a matter of fact, around the wrist, where you want to look a little bit, they blurred it out in one of these documentaries, so you couldn't see it. So it's really interesting. You can't see it. And yesterday, when I saw the release from P&D Robotics out of China, they had what I thought was a pretty good kinematic for a body of, it's like, they're unique. They're doing something like that. It's not bad what they had, but their robot never had hands on it. But they're now showing some robots that you can see that they have hands on it, and the whole thing is blurred out. It's like, oh, they don't want us to see how they're doing it. They don't want to count the fingers. They don't want us, to see what's going on. So it seems like they may have also come up with something else. So to me, P&D, I think, is like, it's my dark horse favorite coming out of China.
I see.
When I look at all the others, they're doing enough clever, inventive stuff on their own. That's like, we know about Unitree, we know about Fourier, and a couple others there, but that, if I was gonna like pick one of the group that's not others, like, your eye on those guys. But coming back to 1X, it's sort of the same thing, is that they're taking a very different approach. Part of it is like, mechanically, they've had to come up with something that's really good for the home, and also their belief that the data set that you get from the home, there's so many more edge cases there in the factory. They believe they can solve the problem faster than if you were geofencing yourself in the factory, which is the way they look at it. So that's their approach. And they already in September are going to be releasing it, because they're going to be producing these at a reasonably good scale, that hundreds this year, thousands next year, 10,000s a year after that They believe it's very easy to scale, but they already have a beta program like FSD beta, where they're probably going to be putting 100 or more of these in homes starting in September.
In homes, in
And
homes.
not yes, yes, yes. So their data collection, so they're putting it out there, and then next year it'll be even easier. There's a possibility you'll be able to get it, and the price will be like that of a car. Okay, so you'll be kind of surprised by the
30,000,
price when they not. Yeah, yeah. So
30,000.
now it does. Now I don't know if that means that it's ready to kind of follow you around there, or whether you're going to be doing a lot of robotic stuff
Yeah.
on your own,
Yeah.
and trying to train it on how you're doing it. But I had the chance in a spaces on the weekend to ask Barrett a couple of questions, and one of them was like, okay, looking at this thing, it seems like not only is the human motion very good, okay, guys in telerobotic suit, but it seemed like it was almost empathetic. And he says, you're on something there I can't talk too much about, but there's something exciting coming, and that is that they feel a lot of the input to the bot will be reading body language. It won't be that you tell it to do something. So when you saw on that thing there, you saw that the girl was tying her shoes, and anyone seeing someone tying their shoes, oh, you're planning to go somewhere.
Yeah.
And then you see a backpack nearby, you can make the inference like, oh, they're going outside, maybe she wants the backpack. And then you make the, you kind of point and say, hey, there's a backpack there, do you want me to pick it up for you? Would that be a helpful thing? And they're saying that that is kind of the mode of operation that's going to be, that in many cases, rather than just having to ask it to do something, it will anticipate ahead of time what it is you need. So it's like, you pull up in the driveway with a car, and like you get ready to get groceries out. Well, everyone sees that, and it's like, oh, you want help with the groceries, right? You have to be told to come help me. It's like you can kind of see it. This is the way a lot of people operate. And there's also another video.
They're going to be better. So they're going to be better than husbands right out the
yeah, exactly. And there was also a video showing in the kitchen helping someone cooking by picking up eggs and bringing them over, which would be kind of a natural way. So that it's rather interesting, saying that they're starting to discover from the training set some rather interesting emergent behaviors that are coming out, that they start training enough, it's able to kind of make these inferences between some of the things that are going on, read the scene literally, have a certain sense of empathy, and say, oh, maybe this is what I'd be able to do. So that's going to be something interesting for me to track. But getting back to how they've done the actuators and everything, if you were to take the suit off, you would probably notice that there's an elbow joint that looks like anything else, and you look at it and you'd think, oh, it looks like they have an actuator there at the elbow. And their elbow can do what all the other elbows can do, is it can move back and forth this way, and can also kind of turn its hand like that. So you get something on there. And so you would think, oh, they probably have a motor here and a motor here. And they kind of do. You're going to see something there, but it's not doing what you think it is. The motor that's actually here at the elbow, while it is in a sense kind of helping to form the joint that's there, actually making the elbow move. It's got some tendon drives onto it that actually are making the wrist
move.
Yeah. The motor that's making the elbow move is actually back up here in the shoulder, as well as the motor that makes it do this. Okay. Now, what they're really trying to do is they're trying to do whatever they can to move the motors back to the torso as much as possible, to make the arm as light as possible, because the lighter the arm, the less mass, the easier it is to kind of move around.
Sure.
Now, to do a tendon drive is a bit tricky, because if you take any sort of cable like this, it works really good in tension. So if I pull like this, I'm pulling the other hand. But if I decide to push like this, what happens? They're really terrible in compression. So that means they on their winding, they have two tendons. They have a tendon that goes one way, and then they clockwise run another one around this way. So when the motor moves like this and that, it's able to push pull as it's needed to do it. So we're probably familiar with how the Tesla bot wrist works. I mean, we've talked about a lot that they've got these two bars that kind of come in there. They're able to push it around. Well, they're kind of doing the same thing, except they're doing it with tendons. And the result is the wrist is like really sleek. I mean, even thinner than the Tesla bot wrist. Everyone else's wrist is horrible because it looks like they've got a sprained wrist. It's so swollen. But they've managed to make it much thinner at the scale of a human wrist without really having anything else going on there. and the actuator for it is way back here, which means you don't have these actuators stuffed down here like everyone else is doing to try to get the wrist to move. And of course, most people's wrist movements aren't even natural wrist movements. They're all messed up. So I can go through most of the humanoid bots there and just give them like F grades on their wrist designs. I don't like them. There's very
So
few. The Tesla is like the rarest one that I like. This one is even better. It's even wilder on the way they're doing it with how the tendons come through here, because
right.
they're actually building what they call a differential there at the elbow, which
Yeah.
is even a weirder thing. And I was like trying to put it all together. It's like, wait a minute, you've got like a differential going on there, and then you get your next set of motors there that then use these things. Then of course the big thing is like, okay, what are you using for the material? Because a lot of people assume, oh, if you use something like, like on a bicycle, stainless steel, it's like, that's just not going to work, especially, you wind it up, over a period of time, it
It's
it
gonna
has a lot of
smack.
tension, it makes noise, it's going to snap, it stretches and stuff like that. Well, they're using some synthetic materials, and I suspect they're using Vectran, which is like one that like just about everyone uses for a variety of things, because you can get a pretty good turning radius out of it. It just doesn't stretch. It's very light. It doesn't make any sort of sound. It's affordable. So yeah, there's some interesting things about them, and going forward, and how they make it light and how they're actuating everything. Because everyone else has two ways of actuating. One, you build the motor right at the joint,
Right.
so that motor becomes
Right.
the joint itself.
Mhm.
And the other is you put a hinge joint there, and then you you make it look like a door hinge with a door opener on it,
Right. Right.
which is like a linear drive of some sort, or something that's linked onto something else. So those are like the standard ways everyone else is doing it. It's like they're either doing this or doing that. And now looking at 1X, wow, they came up with a completely different way, and it's very novel. And they also have these high torque, low mass, low gear ratio motors that provide just enough torque of what they need to be able to do. So
So
that's
what comes to my mind here? First of all, the
Mhm.
first thing that came to my mind was playing with
Yeah,
my Rector set 60 years ago,
yeah,
70 years ago.
yeah.
Anyway, but the second thing that comes to mind, and all the ways that you could use that as
Yeah, you had a motor down here, and you
yeah, playing with
had some
this,
sort of
try to,
cable that came up there, or string, whatever. And it actually, that's where you get a lot of inspiration. He said when
yes,
he was a kid,
yes,
looking at excavators and stuff like that, and understanding how that works. And well, most people do that with like hydraulics.
yeah,
So some of the other hands out there that look very, very good, they're using hydraulics to be able to do it. And it's like, that's not really
yeah,
the way you want to do
yeah.
it. So getting to something that's more like a tendon is pretty cool.
So the second thing that comes to my mind is that you've got now probably 100 or more companies out there trying to do this. We had, you guys had identified about 65 just about a month ago. Now it's probably over 100 given the show that they just had. So you got 100 companies out there, and some of them, have some really good robotics engineers, and you've got a lot of people getting into the game. So you got a lot of inventiveness taking place. We can see, and you're showing, something radically different than what Tesla, who's probably the leader, is showing a month ago or 6 weeks ago. So the change, the potential for even crazier and wilder changes is huge coming downstream.
Oh yeah, 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 yeah. And that what's interesting is that you've got a lot of companies that are trying to solve the problem with different approaches, which
Yeah,
is the best way to do it.
yeah,
If you're looking over, everyone else's shoulder to see what they're doing, you're not going to be creative enough.
yeah,
And if you listen to the interviews with Barrett, and even if you listen to some of the post interviews that like Brett Adcock did with Peter Diamandis, you could see they almost went to the Elon Musk school of business.
yeah, yeah.
They have like the same philosophies,
First
flat
principle.
hierarchies. You don't need this big complicated C-suite. Really being able to be capital efficient. This founder's kind of mentality, being very focused, the way you do your mission, and the idea that being vertically integrated, they're all like, we're not outsourcing this stuff because your destiny is controlled by that. And
Yeah,
we can see that what's the difference between Boeing and
yeah,
SpaceX? Is
yeah,
Boeing is not vertically integrated. Their whole problem is coming from like the sub, at least that they're blaming it on. They're blaming the thrusters on Aerojet.
And most people
Yeah.
don't, and most people, Scott, don't realize that the reason companies like my company, I wrote an article for Inc. magazine called Virtual to Vertical, because we went from 100%
Yeah.
virtual to 100% vertical. And the reason wasn't to save money. Well, a couple of times it was, but most of
Yeah.
the time it was quality, because
Yeah.
you're asking a supplier to provide you with a certain level of quality, and it could be something as simple as color, and they can't even get the color match right, much less
And
if it's a,
time and time to market and stuff like that. So if you want to control your destiny, you want to bring as much of that in-house as possible. Now,
absolutely.
there's some point where you can say we don't have to bring it in-house. Like, it's like if we need nuts and bolts, we can just go down to the hardware store and buy the nuts
Right.
and bolts we need,
Right.
because
Right.
generally they're all of a certain standard. Unless, of course, you're an aerospace company, in which case you may want to, because a lot of aerospace bolts have like really, really high tolerances and standards.
Extreme.
And there's always this concern of like these counterfeit kind of stuff like that. So many cases, you've got to check your suppliers out and make sure what is it that they're doing that they can actually provide something for you that you can't do better.
Right.
But if you understand what yours is, you want to bring more and more of that in. So it's interesting. All these other companies are realizing that, because I remember in the 90s, the trend was outsource like crazy, make everything lean, stuff like that, is, really focus on what you have. And it got to the point that really knew what they were doing. They're just buying everything off the shelf. And now everyone realizes you have to customize it and build it yourself. You want to do it. And then when you start outsourcing this stuff, basically you're giving part of the profits away.
Yeah.
So if you can figure out how to manufacture these things, and a lot of them, they're coming up with their own winding machines. That's what 1X is doing, is they've decided to do it. And that was, and that's, if you listen to any of the normal VC playbooks, like, oh no, you don't do that. Go find someone that was already doing the windings. And you're like, no, they can't. They can't react fast enough.
Yeah.
So what we want to do is we want to bring more and more of that in there. So if you listen to it, it's all very interesting. And Barrett's feeling is that, which I absolutely agree with, is that it's really nice to see some of these companies kind of come in and not even look at what everyone else is doing, try to solve the problem themselves, discover the same things, and always do first principles kind of analogy. So again, this word comes up again, first principles, and then design for manufacturer, co-locating your engineers with your manufacturing, how you get to scale. Listening to all, say, yes, we've heard this before, because we know that is the successful way that Tesla has done. So a lot of people will say that the biggest advantage that Tesla has is that, their manufacturing prowess. They know how to manufacture, and none of these other startups do. But I remind everyone, 20 years ago, Tesla didn't know how to manufacture anything either. Okay. It was something that, so we know that it's not impossible for other companies. It doesn't mean they will.
Right.
And
Or there'll be
a lot of work to get there, but they understand it. I mean, the thing is, they understand the importance of it. They understand, if you want to manufacture, you've got to do this right. You've got to have your design engineers and your manufacturing engineers right there, so they understand what's going on. And you can see that in legacy OEMs, is like manufacturing is in a different state, and like the R&D is like often some R&D center over here, and like every now and then they fly back and forth or something like that. They're not co-located. They really don't know what's going on. They can't understand the product design. So the closer you bring those things together, and what's nice to see, these other companies are getting that and doing it, and then looking at novel approaches. It's like everyone else is solving something, and just because they say, oh, it can't be done, we looked into it. It's like, okay, they looked into it 30 years ago.
Yeah.
Things have changed. Material science has changed. Computers have changed. Control systems have changed. There's all these things. So just because someone wrote a paper 30 years ago to say this is impossible doesn't mean you don't go that way. Tendon-driven systems. I never would have gone with a tendon-driven systems 20, 30 years ago, because how do you control them? They're like really hard to do. But with AI,
it's a whole new world.
Lot easier. You don't need to write these out. It's so things get to be very, very different as you begin to realize, we've got these other tools we can bring to bear that now make something that seemed like feasible, crazy, as something that could be actually quite a reality. And and as far as Barron thinks, his closest competitor is probably going to be the Tesla bot. Because the good design team and everything else is going on there. But they're taking a very different approach. There's no doubt about it. The design of the bots, the actuators is different, and going straight to consumer. It's exciting to see someone take a different approach, because who knows what's going to work. So being here is more as like, the sports broadcasting observer. I like all the teams. Okay.
Yes,
So, it's not like I'm going to say good one. I like watching them and seeing what they're doing and say, hey, let's see if their strategy is going to work this year,
yeah.
versus someone else. And,
Well,
and
and
now
so,
there, yeah. So I think the last indicator we haven't really had an Optimus update, but
right.
there was a post that Elon put out last night that he said he just left Palo Alto. He said mostly good things, a few bad, but there's going to be like lots of robots. Something about a number. Now it's one of those cryptic posts to try to figure out what's going on. So it sounds like he saw a bunch of things going on with Optimus, so probably progress in a lot of areas he likes about. Maybe one thing that's still a problem. We don't know what that is.
Right.
But there's something about the scale of the bots. But we know he's talked about there's going to be a lot of robots at some point. Anyways, I don't think he's talking about that next week. There's going to be like a ton of them.
Right.
But that again, his vision, long-term vision for the future. So I wouldn't read into it saying that 10,000 bots next year.
Yeah. Yeah.
But
anything
we know
but anything,
he's on the record of a couple thousand
yeah. Yeah.
next year, which would be the pre-production. And it's just a question of like, how close are they getting to that goal? And are they seeing a hiccup? Now, if I was to guess what may not be going so well there, I bet it's not walking fast.
Mm.
There's probably like a lot of other things that's going great with the AI and the training stuff like that, but they may be finding that they're not getting the walking speed that they want to get.
Mm.
And I think we're getting some hints why.
Okay.
Okay. And that is, all of the North American bots are walking slow. All the Chinese bots are walking fast.
Mm.
And it turns out it's a choice on the actuators and the control systems that the Chinese bot manufacturers, either because they knew what they were doing or just, they was a bit more convenient with like these drone type of motors, of actuators, which have very low gear ratios.
Mm.
And so they have these low gear ratios, and it turns out with low gear ratios, it's a lot easier to use reinforcement learning for walking, which is what they've done. Whereas high gear ratios, you need classical controls and everything else. So, and it's going to also impact you on your walking speed and everything. So there's like a lot of dynamics and a lot of reasons that there may have been some design choices on how to do the actuation of the legs that are turning out are actually making it harder to get the walking speed out of them they want.
I see.
So that might be something that changes in the Gen 3 bot. That I have a feeling, we're seeing the whole hand is changing. Right?
Yeah. Yeah.
And I kept on saying it's not stopping there. It's going to be going on to more. And you remember, I keep on saying like these companies are always designing like the next bot.
Yeah.
It's already on there even when this one is out. Well, there were Peter Diamandis had a conversation with Brett Adcock like a week or so ago that most people didn't know it, and I listened to it. And then there Peter says, oh yeah, I saw the design for the figure 3 bot.
Yeah.
It's like really impressive. I'm like, what? It's like they just announced the figure 2 and they've already got this other one on the books, and Brett's just like, what? He didn't want to say anything. So it's like, yeah. And of course, I've told on Herbert's channel that I'm such a genius. There's going to be a figure 3 and a 4 and a 5, and there's going to be a Gen 5 Tesla bot, because we all know that's going to happen. And then Barronty even said that in his interview that, that he has a hard time finishing a project. He says he gets it up to a certain point, and then he's off to the next one, and his team got to finish it for him. And there's a lot of people
every entrepreneur. Every entrepreneur.
Yeah, I'm that way too. Is I get so far, and then other people, Da Vinci was that way too. He could never finish anything. He would get a lot of stuff and he'd go off somewhere else. So that's just kind of the nature of these people who are creative geniuses, and that's fine, because you have the people that come in and finish it for you. And then he was already saying that, oh, we're coming out with the Neo, they're finally going to announce it. And he's like, oh yeah, but the Neo 2 is just so good. So he already got, spilled the beans on that's like, they're already deep in the weeds on what the Neo 2 is going to look like. So, you can imagine it's like, oh, okay, so yeah, we knew Tesla Gen 3 is going to come out. It's going to be very different. And it may be that, they realize that it's been a struggle to get the walking speed that they want. They've gone through a couple of generations of it, and it's not going on there. And I think what they're probably going to do is they're going to change the whole approach to the legs. I mean, it seemed like an obvious, elegant one at first, and then this is where you have to realize when you look at the equation F equals ma, sometimes people get misled that if I create a lot of force, I can create a lot of acceleration. And in the torque drives that the Tesla bot has, we've seen it can lift a grand piano. So it's able to generate a lot of force.
Right.
And what that means is it can generate, let's say, a lot of static force, but doesn't necessarily create a lot of dynamic force.
Yeah.
So in order to walk fast, not only do you need to have, fast joint speed, you got to have the acceleration to get you up to that joint speed. And if your gearing and stuff like that kind of limits what you can do there, you may never be able to generate the speed or the acceleration that you need to get that swing that you need to kind of come back. Now, it may be that when you lock it and push against it, it's like, oh, look, I can generate a lot of force when you want it.
Right.
But when you kind of take it off there, it then can't really generate the acceleration that you want to have. So you got to be very careful how everyone looks at that equation, F equals ma. And, the assumption is, wow, they're producing so much force being able to lift a grand piano, it must be able to produce acceleration. I think they can't because the gearing is screwing it up.
Yeah.
And you've got to get more to a direct drive kind of approach.
So I think the other thing that's holding things up, and maybe it'll be solved as of yesterday, is we still don't have the voice and the conversational integration. And I don't think you come out with this. You don't come out with it maybe even in your factory in any quantity until you've got that conversational coordination.
Okay, so are you talking about Colossus, the Foreman project?
I just mean that Grok has to be part of the deal. Grok has to be.
Oh, yeah. It's always been talked about. It's going to be in there.
So
that was Elon said it at the shareholder meeting. He was asked directly that.
Yeah.
And he said, yeah, it's going to be in there, and they're working on it. And I think what you're
coordinating that may not be the easiest thing in the world. That might be another complication that's bigger than anybody thought.
Oh, okay, it could be, but you need to compute for that, right?
Yeah.
And that means that's what you're referring to
yesterday.
Memphis.
Yes.
Memphis. Yeah. And that's Colossus.
Oh, I'm sorry. I didn't.
That was Colossus. And of course, when I heard the term Colossus, I'm like, oh, the Foreman project. But I guess Colossus is also the name for one of the other earlier computers that are out there. But still, see, what was you get Cortex, which is an innocuous. I think that Cortex came probably from also some other sci-fi novel. I'm not sure which, but yeah, Colossus, the Foreman project, things didn't turn out so well. All right.
So you and I have we've made a tremendous number of predictions over the last couple of years that we've been doing this. And I'm going to make another one right now. Maybe you'll agree, maybe you won't, but I'm going to say that there's going to be a number of acquisitions over the next 12 months that because of all of these brainiacs, and usually at this level in a new industry, a lot of the acquisitions are going to be to get the brains, not just the patents, not just
yeah. There's going to be a lot of strategic mergers.
I think there's going to be some strategic mergers, and I think Tesla has shown while that's not their number one way of doing things, the number one way of developing, they're not afraid of it. If they see something that they think they can grab, or some person that they think that they can grab, or a group of people.
Oh, they've done it like with Maxwell, with was it Gorman in Germany. So yeah, they've purchased companies strategically because and also in some cases for IP, not necessarily for the people.
Yeah.
For the Gorman manufacturing, I think that was like for the people and some of the tech and everything else they had there.
Right.
And then see the wireless charging, remember?
Yeah.
They basically bought the company, I think, for the IP, and then sold it all the other parts off back.
Yeah, so I wouldn't be surprised at all to see some moves along those lines, because these small companies, sometimes they're not looking for an exit, but they are limited by how big they can get, or they're limited by some of their own capabilities, and maybe they don't even want to do it. I didn't ever, my personal goal in life was never to be a manufacturer. I have an undergraduate degree in psychology and a graduate degree in law. I was not planning to be a manufacturer, but that turned out to be my story. Yeah, that's where I ended up. But I'm not sure Elon intended to be a manufacturer. It certainly wasn't his background either. But he's turned out to be one good one. All right, Scott. Well, there you go. So 1X.
And
One X.
And it turns out the name 1X it was the name of the household bot in Futurama.
Okay. Okay.
I wasn't deep enough into Futurama to realize that when it came out. You know, it's like Bender, I remember, but you know, I didn't realize it was actually a 1X.
Yeah, well, maybe that's part of the reason why the unveil on 1010 is going to be at the studios, is maybe we're going to also have a bunch of bots walking around with machine guns or who knows what.
Oh, I mean, at Westworld, kind of yeah, who knows? Yeah, that's going to be interesting. I haven't had a chance. I got the update for my hardware 3
Okay.
with FSD. So I think only about 2 or 3% actually got that, because
Yeah.
a lot of the early reviews was that it was like a big regression from the earliest one. But I haven't been back to Florida to test it out, so it's been
there
sitting
you
there.
go. Okay.
So I'm not able to weigh in whether it was good or bad, but I see that it looks like there's another update going out. I'm not sure if that's going to be for hardware 3 as well. So I
Yeah.
haven't been able to test that. I haven't been able to test the actual smart summon
Right.
to see what that is, but it's rather interesting to see the, you know, going through a Costco parking lot.
Oh,
But
yeah.
but
Yeah.
as far, but you know, I you know, until it works in my Costco parking lot, I'm not going to believe it, because
Well,
my Costco parking lot, I'm going to tell you, is the craziest of every Costco parking lot. No one's even close to as crazy as the one I'm at.
well,
Yeah.
I can tell you that as we end the program and just before we go live in in an hour from now, roughly, the Tesla is up $11 a share today in a down market. So I think
Wow.
the
What's the news?
FOMO is finally
1010?
starting to happen around. I think it's probably because of the ASS. I think that the
Oh
ASS.
yeah. That along with 1010. So you
Yeah.
see that and you begin to realize, oh,
Yeah. Oh,
they are getting the
yeah. Yeah.
what? Well, I don't want to call it the last mile problem. You know, it's
Maybe
the
the
last
first.
it's the last meters problem, or the last yards problem. That's really what it is. I mean,
Yeah. If it can do this.
it can pull up to my house. It just can't pull into the driveway. That's not the last
Exactly.
mile problem.
Yes. All right, Scott, as always, thank you so much for bringing us up to date in the robotics area and space. We usually like to have you bring us up to date on space, and it sounds like next week we should have plenty to talk about on the space space front. All right.
Should be interesting.
Okay. And to all of you out there, it's been great talking to you.
Yep. I know.